Fluid Coding and AI is looking at OWL Alpha, OpenRouter's stealth alpha model with free tokens, a million-token context window, and a very real privacy catch. The question is not whether the label sounds exciting. The question is whether developers should actually trust it for coding agents, long context work, and automation. Here is the offer as OpenRouter presents it. The model is called OWL Alpha, with the slug OpenRouter/OWL Alpha. The model card shows a release date of April 28, 2026, a context window of 1,048,756 tokens, and $0 listed per million input and output tokens. OpenRouter describes it as a high-performance foundation model for agentic workloads, native tool use, long context tasks, code generation, automated workflows, and complex instruction execution. For agent builders, that combination lands right where the market is hungry. A huge context window can hold more of a repo, more logs, more tickets, more contracts, or a larger project plan. Free listed pricing makes experimentation feel almost frictionless. OpenRouter also says OWL Alpha is compatible with Claude Code, OpenClaw, and other productivity tools. So the pitch is clear: bring it into a coding workflow, wire up tools, and see how far a stealth alpha model can go. The word alpha matters. It can mean early access, fast iteration, and unusually generous limits. It can also mean unstable expectations, unclear long-term availability, and less public detail than a mature named release. The stealth part is tempting because people want to guess which lab is behind it, but community speculation is not evidence. For a developer, the useful question is simpler: what can the model do? What are the terms, and what risks do you inherit when you send it real work? The privacy detail is not hidden. OpenRouter's OWL Alpha page includes a model-specific notice that prompts and completions may be logged by the provider and used to improve the model. That is different from OpenRouter's general FAQ, which says OpenRouter itself logs basic request metadata and does not log prompts or completions by default. Provider-side policy can differ. For proprietary source code, customer data, credentials, private documents, or regulated workloads, that distinction should change how you test this model. A million-token window is valuable, but it is not the same thing as guaranteed understanding. Long context lets you provide more input. It does not prove the model will retrieve the right detail, maintain state across a long task, or finish a multi-step workflow correctly. This matters for coding agents. Stuffing an entire repo into context can reduce missing file problems, but the host app still needs tests, targeted retrieval, tool boundaries, and checks for incomplete or malformed answers. The local benchmark gives us a more grounded read. In one first-party LLMBench coding run through OpenRouter, using OpenRouter/OWL Alpha, OWL Alpha scored 1385 out of 2100, or 65.95% across 21 coding cases. It was strong on the easy tier, with 4 clean passes and 1 partial. The medium tier was mixed. The hard and very hard tiers exposed real problems, including weak scores on scheduler, webhook, replay, and migration tasks, plus 1 workflow orchestrator case that timed out after 90 seconds. That benchmark does not prove universal model quality. It is one provider and model invocation on one local coding suite. It does not measure writing, math, multilingual behavior, retrieval quality, safety behavior, latency, cost stability, or production uptime. But it does support one careful claim. OWL Alpha handled several straightforward coding tasks cleanly, handled some API work, and struggled on a number of harder workflow and orchestration cases in this run. That is useful evidence as long as we keep it scoped. OpenRouter's tool calling docs make the agent story less mysterious. The model does not execute tools by itself. It suggests a tool call, your client validates the arguments, your app runs the tool, and the result goes back into the conversation. So when a model card says native tool use, the host application still carries a lot of responsibility. It needs safe schemas, argument validation, error handling, loop limits, permission checks, and a way to decide whether the final answer is complete. OpenRouter's routing layer is useful, especially when providers are down, rate-limited, or erroring. Developers can set provider preferences around order, fallbacks, data collection, zero data retention, price, throughput, and latency. But fallback is not a quality filter for every bad answer. If a model returns a technically successful response that is incomplete, malformed, or just wrong, your app may need its own validation, retries, test execution, or human review. Routing helps availability. It does not replace judgment. My practical read is this. OWL Alpha is worth testing for non-sensitive coding experiments, long context trials, and agent prototypes where you can measure the output against your own workload. It is not something I would blindly wire into production autonomy just because the token price is listed at 0 or the context window is huge. Treat it like an interesting alpha. Avoid sensitive prompts, benchmark your actual tasks, use explicit fallbacks, and put validation between the model and anything that matters. If this helped you separate the OWL Alpha hype from the usable developer signal, like the video and subscribe to Fluid Coding and AI for more grounded AI model and coding agent breakdowns.